Hello my dear friends, beloved students, welcome back to C-Level Physics. My name is Srinivas. Today I would like to explain one numerical related to horizontal projection. Here, two bodies are projected simultaneously along horizontal with their own velocities from the top of tower as shown in figure. See here, this is what? The tower of certain height. Now here is the top of the tower. So from this tower, two bodies are projected horizontally opposite to each other. Right? Now they take their own parabolic paths like that. See, this is what parabolic path for the first body. Right? This is what parabolic path for second one like that. So this is what ground. Okay. Now the question is the time after which their velocity vectors perpendicular to each other. Right? Now see, suppose as far as first body is concerned, in a given time t, this is the position of the particle, right? Now coming to second one, this is the position of the particle, right? Suppose I want to specify its instantaneous velocity at this position. See, this is what V1. V1 means instantaneous velocity of first projectile, right, which is projected rightwards along positive x-axis. Okay, so here this is the instantaneous velocity of the first projectile, which is projected along positive x. Now coming to other one, which is projected towards negative x-axis. So this is the position for that particle, right? Now this is what instantaneous velocity. Let it be V2. V2 is the instantaneous velocity for this projectile. Now I am extending these two velocity vectors. Right? They are produced behind like that. Okay. So this is also extended like that, such that they meet somewhere here. Right? Now what is the angle? What is the angle here? 90 degrees. Okay. The angle between V1 bar and V2 bar is 90 degrees. Then we can say that at that instant, both projectiles moving perpendicular to each other. Why? Because this is the velocity vector for this projectile. This is the velocity vector for the first projectile. Okay. At some instant. Now, if they are produced behind, such that to meet somewhere here, what is the angle between these two velocity vectors? Somewhere here. See, this is what? Extended vector. This is also extended vector. Right? Now, both meet somewhere here. What is the angle here? 90 degrees. So, 90 degrees. Right? Now, the question is, for those projectiles, if velocity vectors are perpendicular to each other, what is the time taken to happen like that? That is the question. Right? So what I am doing means here, this velocity vector is to be resolved into two components. One is along x-axis, that is Vx for first projectile. This is what? Vertical component, that is Vy for the first projectile. Right? Here also, if velocity is divided into two components like that, see this is what? Vy for the second projectile. This is what? Vx for the second projectile. See, V2 can resolve into two components. One is along x, another one is along y. Here also, V1 is resolved into two components. One is along x, other one is along y. Okay. Right? Now, I am trying to express those components. Right? See, this word tower, right? This is what tower. I am writing components for the first projectile, which is projected along positive x-axis initially, right? What is x component? V equal to u plus at, right? V equal to u plus a. That is Vx equal to ux plus ax into t. Okay. Now what is ux? Ux means u1. What is the initial velocity along horizontal? That is u1. So u1. Okay. Now what is acceleration along x-axis? 0. 0 into time. Why? Because there is no force along x-axis. So 0, acceleration is 0 into time. So Vx1. So Vx1 equal to u1. Similarly, for this one, V equal to u plus at. V equal to u plus at. That is Vx equal to ux plus ax into t. Am I right? So that is Vx for the second projectile equal to ux. What is ux? U2. U2. That is towards negative x-axis. So therefore minus u2. Minus u2. Plus ax means 0. 0. Right? That is Vx2. Vx2 equal to minus u2. Vx2 equal to minus u2. Why? Because that is acting towards negative x-axis. So these are x components for both projectiles. Right? Coming to y components, take the same expression for first one, that is v equal to u plus a. That is vy equal to ui plus ay into t. What is vy? Vy for first one, that is uy. What is the initial velocity along vertical here? That is 0. Why? Because entire velocity is given along horizontal, so there is no component along y-axis at time t equal to 0. So uy 0 plus ay means minus g, acceleration due to gravity acting vertically downwards. So minus g into time. That is vy1 equal to minus g. Okay, coming to second projectile. What about component y component? That is, take v equal to u plus at once again. That is vy equal to ui plus ay into. So vy for the second projectile equal to uy. See, what is the initial velocity along vertical at the point of projection? Is there any initial velocity at the point of projection that is towards negative y-axis? No. Why? Because entire velocity is given towards negative x-axis. That is uy 0 plus ay means minus g into time. So vy2 also equal to minus g. So both components negative only. See, this is what acting downwards. So v equal to gt but with negative sign. Here also vy2 acting downwards. So vy2 equal to again gt. Why? Because initial velocity 0 in both cases along y-axis. So minus gt as per sign convention. So minus gt. This is what? u1 plus u1. This is what? Minus u2 negative x-axis. So we can express instantaneous velocities v1, v2 in terms of components. Right? Now what is v1? v1 bar equal to, that is vx1 into I cap plus vy1 into j. That is v1 bar equal vx1. What is vx1? That is u1. So u1 into I cap plus vy1 minus j. Negative sign is already taken. So minus gt into j cap. Don't take negative sign for j cap. Already negative sign is taken. Okay, no need to write minus j here. Already taken. So that is plus or minus gt into j cap. Right? So this is what? Instantaneous velocity for first projectile, which is projected towards positive x-axis. Similarly, we can express v2 also in terms of components. That is v2 bar also can be written as vx2 into I cap plus vy2 into j cap. Right? That is v2 bar equal to vx2. That is what? Minus u2 into I cap. In fact, that is minus I cap. Already negative sign is taken, so no need to take one more time. That is minus u2 into I cap. Minus u2 into I cap. Minus gt into j cap. See, Vy2 minus Gt. So plus minus Gt into J cap. So here also already negative sign taken. So don't take one more time. Plus minus. So okay, that is V2 equal minus U2I plus or minus Gt into J. So these are the given vectors. Instantaneous velocities for both projectile after t seconds after the projection. See, this one time t equal to 0 here. Here time t equal to t. Here also time t equal to t. Right? Here time t equal to 0 here. Here 0. Here time t equal to 0. Okay. Now from the question, V1 bar perpendicular to V2 bar. See, V1 bar perpendicular to V2 bar. Here, see the angle. This is what? V1 bar. This is what? V2 bar. What is the angle between these two? That is 90 degrees. So for two perpendicular vectors or two orthogonal vectors, their dot product must be 0. Right? So V1 bar perpendicular to V2 bar implies V1 bar perpendicular to V2 bar implies V1 bar dot V2 bar must be equal to 0. Now take the dot product of these two vectors at 0. So V1 bar dot V2 bar. So I dot I 1, J dot J 1. So how to find dot product? The sum of similar components. See, X component multiplied by X component, Y component multiplied by Y component. So V1 bar dot V2 bar, that is U1 into I cap minus Gt into J cap dot V2 bar minus U2 I plus or minus minus Gt J equal to 0. Okay. Now I dot I 1. So U1 into minus U2 minus U1 U2. Right? So I dot J 0. No need to write. Again, J dot I 0, no need to write. We left with J dot J means 1, that is minus or minus plus Gt into Gt, Gt square equal to 0. Right? So Gt square, that is G square T square equal to U1 2. Right? Implies P equal to root over U1 U2 by G. So T square equal, see here T square implies T square equal to U1 U2 by G square. So make it subject G and T, that is T equal root over U1 U2 by G. So this is what? The time after which both projectiles move perpendicular to each other. See, the angle between V1 bar and V2 bar becomes 90 degrees after this much of time, that is T equal root U1 U2 by G. Now, by that instant, what is the separation between these two projectiles? What is the separation here? Suppose here, what is the distance here from here to there? Say x1. Here, what is the distance here? x2. Now, x1 plus x2 becomes equal to separation, normal separation between the projectiles by that time when their perpendicular, when their velocity vectors are perpendicular to each other. Otherwise, by that time when they move perpendicular to each other. See, this distance is x1, this distance is x2. Now x1 plus x2 becomes equal to separation between the projectiles. Right? Now next point, separation. D equal to x1 plus x2. That is x1. x1 means, sorry, this is what x2. This is what x2. This is what x1. Right? x1, x2. So x1 means horizontal distance. So horizontal distance means horizontal speed into time. Why? Because there is no acceleration. So x1 equal to u1 into t. So u1 into t. u1 into t plus x2. What is x2 here? x2 means horizontal speed u2 into t. Why? Because there is no acceleration. Uniform speed, uniform motion. That is u2 into t. So what is the separation? D equal to, T is common here, U1 plus U2 into time. That is U1 plus U2 into time means root U1 U2 by G. So D equal to U1 plus U2 into time root over U1 U2 by G. So this is the separation between the projectiles for the situation when they move perpendicular to each other. So this is the separation between these two. This is the time after which they move perpendicular to each other. Okay. So coming to, if I substitute numerals, for example, what is U1 here on numeral? See, what is U1? 5 meters per second. What is U2? 20 meters per second. Right? Here, two bodies are projected horizontally opposite to each other from the top of one tower, vertical tower, with the speeds 5 meters per second and 20 meters per second respectively. Now find the time after which they move perpendicular to each other. See, they take their own parabolic paths. After this much of time they move perpendicular to each other. Now what is the time? Root U1 U2 by G. U1 means 5, U2 means 20. Here no need to consider negative sign. Take positive sign. So why? Because already sign convention is taken somewhere here. So here no need to substitute sign convention. Take positive, that's all. That is T equal to root U1 U2. U1 means 5 into U2 means 20 meters per second divided by G means, for example, 10. Otherwise 9.8. Here take it as 10 meters per second. That is 5 into 20, 100 under root, that is 10. So 10 by 10, 10 by 10, that is 1 second. 1 second. So after 1 second, right, they move perpendicular to each other. Now what is the separation between these two? In 1 second, that is when they move perpendicular to each other, that is the separation. D equal to U1 plus U2 into time. So here U1 plus U2, 5 plus 20, 5 plus 20 into time, that is root U1 U2 by G. Already found here. Root U1 U2 by G, that is time, 1 second. So into 1, that is 5 plus 20, 25 meter, 25 meter. This is the separation between these two projectiles when they move perpendicular to each other. See, x2 plus x1, otherwise x1 plus x2. This is the separation. See, this is what separation. This is what separation between these two. Right? So that's how one can find separation between the projectiles and time after which they move perpendicular to each other. If they are projected horizontally opposite to each other from the top of one tower, right? Both are projected simultaneously, right? Now coming to one more model. This time I want to know the time after which their displacement vectors are perpendicular to each other. By that time, what is the separation between the projectiles? I don't want velocity vectors. This time I want to specify their displacement vectors. Displacement vectors, right? Displacement vectors. So I am rubbing off. Okay. See, same situation. Here two bodies are projected horizontally and simultaneously from the top of tower, such that they move opposite to each other. Now these are the parabolic paths for both objects, right? Suppose after some time t, this is the position of the first projectile, right? What is the displacement on reaching here means this is the displacement. Why? Because a line segment drawn from point of projection O up to the given position, that is a displacement vector. See, this is what S1. Okay. Now, for example, This is the position for the second projectile at the same instant. Now what is the displacement vector? Take a line segment from initial position to given position. See this what displacement vector. Take a line segment from the initial position to the given position. So this is what S2 bar, S1 bar, S2 bar, right? Now what should be the angle between these two? From the question means 90 degrees. Here 90 degrees. What is the angle between S1 bar and S2 bar? 90 degrees. S1 bar makes an angle 90 with S2 bar. So that means to say that after some time t, their displacement vectors perpendicular to each other. Suppose this is the position for the first projectile, this is the position for the second projectile. Okay. Right? Now what is the time taken by both to have this situation? Right? So this time we have to specify components of displacement along x and along y for both objects. So I am rubbing off, no need of velocity vectors. We need to specify displacement vectors. S equal ut plus half h square. So S equal ut plus half h square. No need of velocity vectors. Okay. S equal to, see, this is the division for both. Right side, first projectile, left side, second projectile. So what is the expression? S equal to ut plus half at square. Right? Now what is S? Is Sx, here ux, here ax. Sx. See, S1 finds two components. Component along x, component along y. S2 also finds two components. Component along x, component along y. So Sx, that is Sx for first projectile, that is ux. What is ux? This is what ux. Initial velocity along x, that is u. u1 into t plus half into what is ax? Acceleration along x-axis 0 into t square. There is an acceleration along x-axis. So Sx1 equal to u1 into t. Similarly, for the second projectile, take the same expression, S equal to ut plus half at square. So Sx, ux, ax. So Sx for the second projectile, x component of displacement for the second projectile. That is ux means u2 with negative sign, that is acting leftwards. So minus u2 into t plus half into ax means 0. There is an acceleration along x-axis. See, acceleration always acting downwards along x, acceleration is 0. Ax 0, ay that is minus g. X equal to 0, ay equal to minus g. Okay. That is Sx2 equal to minus u2 into t. Here u1 into t, here minus u2 into t. Similarly, take y component for the displacements. Y component for the displacements. So S1y, that is same expression once again, S equal to ut plus half at square along y-axis. Sy becomes Sy1 for the first projectile, that is uy. What is the initial velocity along the vertical here? 0. Why? Because entire velocities are given along horizontal. So initial vertical velocity 0 for both projectiles. 0 into t plus half into ay means minus g. Ay minus g into t square. Right? That is Sy1 equal to minus half g t square. Similarly, Sy2, that is Sy equal to uyt plus half ay t square for the second projectile. Same equation. Sy becomes Sy2 equal to uy 0 for the second projectile also. Initial velocity along y-axis 0 into t plus half into ay means minus g. minus g into t square. So sy2 equal to minus of g t square. So both are having same vertical displacements. Same vertical displacements. Okay. Right? I'm representing the same. I'm highlighting somewhere here. See. This is what S1 bar. Here SX1. Here SY1. Here S2 bar. This is what S2 bar. See S1 bar, S2 bar. So S1 bar finds two components along X, along Y. Similarly, S2 bar finds two components. See here. This is what S2Y. This is what SY2, SY for the second person. This is what SX for the second person. See these two components for S2. These two components for S1. Right? Like that. Okay. Right? Now in the same way, we can express displacement vectors. S1 bar. S1 bar. What is S1 bar? S1 bar equal to SX1 I cap plus SY1 J cap. SX1 U1T. U1T into I cap. Right? Plus SY1 minus of GT square. Minus of GT square into J cap. Already negative sign is taken. So no need to consider minus J once again. Already negative sign is taken. Okay. Similarly, S2 bar. S2 bar. SX2 I cap plus SY2 J cap. What is SX2 minus U2T? Minus U2T into I cap. Negative sign is taken. Plus SY2. That is minus of GT square. Plus minus of GT square into J cap. Right? Into J cap. Okay. Now S1 bar and S2 bar perpendicular to each other. See here 90 degrees. So therefore S1 bar perpendicular to S2 bar implies their dot product must be 0. S1 bar dot S2 bar must be 0. Right? S1 bar dot S2 bar, that is sum of products of similar components. So I dot I1 we left with U1T into minus U2T, that is U1T into minus U2T into I dot I 1. I dot J 0, so no need to consider this product. Plus J dot I also 0, so no need to consider these products. Now left with J dot J 1, so we have to multiply these two. That is plus into minus of GT square into minus of GT square. Minus of GT square into minus of GT square equal to 0. Right? Okay, minus of minus plus. One second. Here minus U1 U2 T square minus of minus plus of GT square whole square. See? Of GT square into of GT square. That is 1 by 4 G square T power 4. So make it subject that equal to 0. 1 by 4 G square T power 4 equal to U1 U2 T square. Right? So T square T power 4. We left with the T square. So G square by 4 into T square equal to U1 U2. Implies what is it? T square equal to 4 U1 U2 by G square. 4 U1 U2 by G square. That is T equal to 2 root U1 U2 by G. So what about T equal to 2? This is what 4 t square equal to 4 u1 u2 by g square, that is t equal to 2 root u1 u2, 2 root u1 u2 by g, right? So this is what time after which the displacement vectors becomes perpendicular to each other. What is the time after which their velocity vectors perpendicular is root u1 u2 by g. But what is the time elapsed for their displacement vectors perpendicular to each other means twice root u1 u2 by g. So this takes much time. Okay, their velocities to become perpendicular. Am I right? So t equal to twice root u1 u2 by g. Now what is the separation? Same. So in that situation, what is the separation between the projectiles when their displacement vectors perpendicular means, see, this what x2, this what x1. So what is the separation? x1 plus x2, that is d. So d equal to x1 plus x2. Once again, x1 plus x2, that is d equal to, see once again, what is the separation? D equal to x1 plus x2. x1 means u1 into t plus x2 means u2 into t. u1 into t, x2 means u2 into t. That is u1 plus u2 into t. So separation d equal to u1 plus u2, u1 plus u2 into time. For the time after which their displacement vectors become 0 means, see the time here, 2 root u1 u2 by g, 2 root u1 u2 by g. So into 2 root u1 u2 by g. So this is what separation between projectiles when their displacement vectors perpendicular to each, right? Coming to numerical, suppose u1 equal to 5 meters per second as in the previous case. For example, what is u1? 5 meters per second. What is u2? That is 20 meters per second, right? Previous sum. So these two projectiles simultaneously projected horizontally with 5 meters per second, 20 meters per second, such that they move opposite each other from top of one tower, vertical tower. Now find the time after which their displacement vectors becomes perpendicular. What is the time? 2 root u1 u2 by g. That is 2 into root u1 u2. u1 means 5, u2 means 20. That is 5 into 20 by g. Okay. So root 100 means 10. 10 by 10 cancel. We left with 2 seconds. 2 seconds. Right? 2 seconds. Now what is the separation between these two projectiles by that time when their displacement vectors perpendicular to each other? That is x1 plus x2. So d equal separation equal u1 plus u2 into time. u1 plus u2 into time. So that is separation u1 plus u2, 5 plus 20. 5 plus 20 into 2 root u1 u2 by g means time. What is the time? 2 seconds into 2. That is 25 into 2 means 50 meters. So this is the separation between projectiles by the time when they move, when their displacement vectors perpendicular to each other, right? Okay, so that's how one can find separation between the projectiles and time after which their displacement vectors perpendicular to each other. Okay. Now, small numerical. Suppose 3 bodies are projected in 3 ways from the top of vertical tower, but with same speed. Now assign or compare the speeds with which they hit the ground, right? A small numerical, critical question. Small numerical, concept oriented question. Suppose this is what? One vertical tower, right? Vertical tower. Here 3 bodies are projected Like, see, first one is projected with some speed u such that making an angle 60 degrees with the horizontal, right? So this is what projectile A. Now what is other projectile B? This projectile is projected horizontally with the same speed, like with the same speed u, like what is the speed u? Same as the projectile A. What is the name for this projectile? B. This is what? B, right? Now we have one more projectile which is projected downwards, not vertically downwards, but downwards, such that making an angle 60 with horizontal. Now what is the name for this projectile? C. This is what? C. So A, B, C. We have three projectiles projected simultaneously in different directions from the top of one vertical tower as shown in the figure. Now after some time they meet or they strike the ground somewhere at different places. In fact, different places. Suppose even though it is projected like that, because of gravity it takes one parabolic path like that, for example. Okay, this is what blue in color, that is C. So this is what C, for example. What is the name for this one? C. Projectile C, right? Now projectile B. See, this is what horizontal projectile. So it takes white in color, that is white chalk, takes parabolic path and strikes somewhere. This is what? B, right? Now coming to first one, projectile A. This is projected from the top of tower such that making some angle 60 with horizontal. So it should have some elevation like that, right? And reaches level of projection, but continues to move below the level of projection. So strike somewhere, right? Like this is what projectile A. Now the question is, compare. Question. What is the question? Compare the speeds with which they strike the ground. Compare the speeds with which they strike the ground. This is the question. Suppose here it is VC, here it is VB, here it is VC, VA, for example. Final speeds. But initial speeds UA equal to UB equal to UC. What is the speed? U1. For all the three, U1. Initial speed same one for all the three. Right? What is the speed here? Same speed. U. Right? U. Projectile C. A, B, C. Okay. Now, as far as law of conservation of mechanical energy is concerned, here there is no other force except gravity. There is no other force like resistive force like air friction. So, therefore, mechanical energy remains constant at the point of projection and at the point at which they meet the ground. Right? So, we have to equate total initial mechanical energy equal to total final mechanical energy to each case, for each projectile. So, for example, for A, what is A? Total mechanical energy means sum of potential energy and kinetic energy. That is U plus K. U means potential energy, K means kinetic energy. Initial equal to U plus K final. Okay. Now what is, suppose this is our reference level, ground is our reference level. So this is the point of projection. So all three projectiles start from here on. Now what is the height here? Suppose for example height h of the tower. Now potential energy means mgh from the reference level ground. Right? Initial potential energy means mgh, that is m into g into h. What is m? Whose m here? That is ma into g into h. plus kinetic energy of ma square, half into mass of A into UA. What is UA? UA means you know, U only. That is U square equal to, when it strikes the ground, this is our final instant, this is our initial instant. Otherwise, this is the initial position, this is the final position. See, all the projectiles meeting the ground, am I right? Strikes the ground. So therefore, final position is on the ground for each projectile. So what about potential energy 0? Why? Because there is no height here. This is our reference level. When it reaches the reference level, height becomes 0. Therefore, potential energy 0 on the ground. Thus, kinetic energy for A of M of mass of A into VA square. VA square. Am I right? VA. For example, unknown. VA is unknown. So here MA is common. MA is common. That is MA is common. We left with GH plus U square by 2 equal to MA, otherwise of MA into VA square. MA into VA square. So MA cancel. Take LCM 2GH by U square by 2. 2 cancel. After taking LCM, we left with the 2GH by 2GH plus U square. So 2GH plus U square by 2 equal to 1 by 2 VA square. 1 by 2 VA square. So 2 cancel. So VA equal to root over 2GH plus U square. Alright? VA equal to 2GH plus U square. This is what we calculated for projectile A. This is the speed with which it strikes the ground. Of course, if you do like this, even for second projectile B and third projectile C, you will get the same result. For B, for example. So after proceeding like that, sum of potential energy and kinetic energy at the point of projection equal to sum of potential energy and kinetic energy when it strikes the ground. So initial mechanical energy equal final mechanical energy. So here MB common, here MB common. U for B also initial velocity U only. So you will get same expression. So for B also VB is the speed with which it strikes the ground. VB equal root over 2GH plus 2GH plus U square. Right? Same one. For C, projectile C, if you proceed like that, okay, you will get same expression even for C also. That is VC also equal root over 2GH plus U square. Why? Because here mass will be cancelled on both sides for every projectile. Right? So if it is the first projectile, MA, here MA. If it is second projectile, MB. If it is third projectile, MC, cancel. Okay, independent of mass. The expression is independent of mass here. The speed with which they strikes the ground is independent of mass. Right? So U means initial speed remains same for all the projectiles. Height of the tower also same. G at the same place, G constant, 2 constant. So therefore VA equal to VB equal to VC. That means to say that all the projectiles, even though they are projected in different directions from the same height simultaneously with the same speed, even though they meet at different positions on the ground, right? They strikes the ground with the same speed. VA equal VB equal VC. VA equal VB equal VC. So that's what very interesting result. Okay friends, with this I am concluding. If you are really impressed with my video, please subscribe to my channel. Thanks.